the beat. Bill Nye the Science Guy, oh what a genius, you are the greatest. Bill Nye the Science Guy.
Bill Nye the Science Guy.
Oh yes you are. Oh yes you are. Bill.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Hear that? Ah, it's music to my ears. And to yours. Music can be a tune on a fiddle. It can be whistles blown to a beat. The strumming of a string. Or a song played on the saxophone. Music is made all over the world.
Oh yeah, it's a Logan.
It's a pattern of vibrations in the air. And music affects our senses. Take a look at this. It's our musical sound wave vibration display of science. This is an electronic keyboard. And this is a piano. This is the display of an oscilloscope. It's a device that's connected to a microphone that picks up sound waves in the air and shows them to us here on the screen. Now, when I hit a low note, we can see that the waves are pretty far apart. When I hit a high note, the waves look about the same, but they're much closer together. This is true on the electronic keyboard or on the piano. Now, this is called the pitch of the sound. So this would be a low-pitch sound, and this would be a high-pitch sound. Now, we take these sounds and arrange them in what are called notes of music. Now, notes of music can be close together or far apart. Now, that's called the rhythm of the music, how close together the notes are and how long each note lasts. And there's one more thing. We can play a note softly or loud. So, pitch, rhythm, and loudness, they're all ways to make vibrations of sound that can become notes that can be arranged in patterns to make music. They could be arranged into patterns to become music. Depends on who's doing it, I guess.
Consists of two muscular strips called the vocal cords. As we force air up from the lungs, it causes the vocal cords to vibrate.
This is the difference between a musical note and a noise. Music is a regular wave motion. A noise is an irregular mixture of many wave motions.
Today on the Jackie Smash Show, it's the amazing juggling feats of Yoo-Hoo the Clown.
Jackie, you canceled. Now it's Bill Nye the Science Guy.
And my guest, apparently, is Bill Nye the Science Guy.
Great to see you again, Jackie.
What do you mean? Have you ever been on this show? He's never been on before, has he?
Yeah, once I think.
Lots of times. Yeah.
Let's cut the small talk here, Bill. I want to talk to you about ears.
Yeah.
How do these things work anyway, these ears we have?
Well, we have two of them, most of us, and I prepared a little demonstration. Let me show you. Sound is vibrations moving through the air like this. The vibrations make air molecules move. The vibrations come down this part of your ear to your eardrum, which flexes like the head of a drum, like this. Now, your eardrum vibrates at exactly the same speed as the vibrations of sound. that makes these tiny bones move, and they push on the end of the seashell-shaped tube called your cochlea. Tiny hairs toward the front of the tube pick up high-pitched sounds, and hairs deep inside the tube pick up low-pitched sound. They send signals through your auditory nerve to your brain, and we perceive them as sounds.
So, it's all done with vibrations then, huh?
That's right, Jackie, vibrations.
Vibes, baby.
Well, music is a pattern of sounds. Makes me want to move my body around. It's science, baby. A pattern of repeated sounds.
This is a tuning fork. When I hit it, both sides start to vibrate. 440 times a second. You can hear it when I press it on this fiddle. Now, the vibrating tuning fork is setting up vibrations in the air. Now, that doesn't mean that all of the air is moving like the wind. It means that the tiny molecules of air are tapping against each other. A little bit like this.
Uh-huh.
The vibrations move through the air. They find their way to your ear and to your eardrum. Your ear can detect the tiny movements of tiny molecules.
You can see sound waves for yourself.
Ooh.
Just take a soup can and cut off both lids. Now use a rubber band to hold the plastic wrap tightly over one end. Then glue a sequin to the plastic wrap. Now turn off the lights. Shine a flashlight on the sequin. And then you sing into the can. Ha ha ha. Ba 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 ba. See? The shiny sequin bounces light onto the wall. When you sing, sound waves jiggle the plastic and shake the sequin. Music is vibration. Vibrations of sound.
Yeah. And now, back to the Jackie Smash Show. Now, Bill, music and science. Bill? Music and science, science and music. What inspired you to see science in music?
Well, I brought a clip.
Oh, good. Oh, over here, Bill. Right here.
I remember the first time I learned that music was a series of vibrations. When I danced as a kid, I was causing the floor to vibrate, making the air vibrate, causing sound waves, pleasing sound waves. I was a bit older when I realized that I could make vibrations by blowing into a wind instrument. Vibrating my lips set up vibrations in the tube, and I could vary the pitch by opening and closing holes. And in my teen years, I discovered the joys of vibrating strings.
Wow.
Music affects your senses. It can make you sad. It can make a movie scary. Or it can make you happy.
Hey, that's Kenny G. Music is made of notes, and notes are arranged in groups called measures or bars. So here are 2 whole notes. Each whole note takes up a whole measure. Now, we can divide the measures up into half notes, like this, or quarter notes. See, there are 4 quarters in a dollar, and there are 4 quarter notes in a bar. And we usually call it 4/4 time. 4 quarters. Now, you can keep dividing the music up. For example, there are 2 eighths notes in each quarter note, and there are 4 sixteenths in a quarter, or 2 sixteenths in each eighth. And then you can divide a 16th note, and you get 32nd notes when you divide the 16th up. Or you can have 64th notes, or you can have just 2 eighths on the end of the quarter over there, see, like that. Now, if your musician comes up with something that you like, or then you can write it down. You can record it on the musical notes. See? It's going pretty fast.
Welcome back to Gimme a Tune, where all the tunes are out of tune. Now, give me a tune. Oh, sorry, time's up. That was Home on the Range. Home on the Range.
That doesn't sound like Home on the Range to me.
That's because all the tunes on Gimme a Tune are out of tune. Let's try it again.
I wear my sunglasses at night.
No.
Come on, Eileen.
No.
Oogie, oogie, oogie. Love Shack.
Doesn't quite sound right, does it? That's because it's not quite in tune. The strings aren't vibrating at the right frequency so that they sound good together or good with other instruments. The musician uses a tuning fork that makes the note A. Vibrates at 440 beats a second. He uses his ear to get one string set up to the note A. Now, to make an instrument like this have a higher pitch, you'd make the string tighter. Make it a lower pitch, you make the string a little looser. Then once he gets the first string set up, he can use that note to make the other strings be in tune. Now, once they're all in tune, not only do they sound good, but they sound good with other instruments in the orchestra or band.
Being in tune is important for music because human ears can hear very small changes in pitch or frequency. You can prove this for yourself. Here's how. Here's how.
Pour some water into 2 identical glasses. Use a spoon to tap each glass and compare the pitches. Add water to lower the pitch of the glass that sounds higher. A little at a time. Repeat this process until both glasses are in tune or play the same pitch.
As the frequencies get closer to each other, hearing the differences gets more difficult, but you can still hear because your ears are very sensitive.
Inside your head.
Try it!
Now divide in half. Plonk again. You see? It's the same tone, 1 octave higher. Now divide the next section. And the next. Pythagoras discovered the octave had a ratio of 2 to 1. With simple fractions, he got this. And from this harmony in numbers developed the musical scale of today.
By writing music down, we can record it, and other musicians can play it. Now, we write words on a line from left to right. So people came up with the idea to write music on lines from left to right. So we start down here. This turns out to be E. And above that is F. Then G, A, B, C, D, then E again. The top line would be F. See, once it's written this way, we call it musical notation. And then somebody like Chase can play a piece by Bach or Mozart, and those guys aren't exactly around anymore, to hum it for them. See, musical notation is science.
So, Bill, let's talk about rhythm. Now, what the heck does that have to do with anything?
Well, Jackie, music isn't just a pattern of tones and pitches. No, it can be a pattern of beats. That's all, a rhythm.
So what you're saying is that a pattern of beats can affect the sound of music and even work as music itself.
That's exactly right, Jackie. Just as the taps on our feet make a pattern of beats, sticks on a drum make a rhythm too.
We're here with Bill Nye, the Science Guy, and we're talking about science. Oh, no, I'm talking about music. Well, no, science. Is there science in music, Bill?
Music is packed with science, Jackie.
So what you're saying is there's science in music.
Oh, yeah. It's vibrations, sonic sensations that rattle the air in a wave we can ride. A wave of emotion. I've got a notion. It's a journey we take through our eardrums inside.
So just what you're saying, the music I'm playing is making it swaying to my tiny brain.
It's really astounding when the music is pounding. It's all just lovely patterns of sound.
There's science in music, oh yeah. There's science in music, oh yeah.
Vibrations leap through the air.
And they get into your ear. Every culture has music, and the pattern is clear.
The thumping beating of drums,
The rhythm tuning of reeds,
and blowing, blasting up brass, and swinging, plucking up strings.
there's science in music, oh yeah. There's science in music, oh yeah. It's just so filled with emotion. This sound waves in motion. Music makes us cry, then makes us laugh, or makes us feel tense, or filled with suspense. By music inflected, our senses are affected. There's science in music, oh yeah. There's science in music, oh yeah. Music can affect you emotionally, it can even make you react physically.
Whenever I hear that funky sound, I just gotta throw my body around.
My heart starts thumping, my brain starts to groove, and before I know it, my feet start to move.
There's science in music, oh yeah. There's science in music, oh yeah. There's science in music, oh yeah.
Well, that's our show. Thanks for watching. If you'll excuse me, this music is affecting my senses. See ya.
Produced in association with the National Science Foundation.
Anyway, it's fascinating, really, music. High sounds over here, low sounds there, mixed together with a rhythm, da-da-da-da-da, like that. It's beautiful. Flows. It affects your senses. Sure it does. Affects my senses anyway. I mean, coming from over there, and it just comes into your ears, and it's a pattern of vibrations. So music is really a pattern of vibrations. You know, this music is kind of making me think, kind of making me reflect on the show and the science of music, really. I hope it affects everyone that way. I hope everybody watching this thinks about patterns of vibrations, patterns of sound. I'll tell you what it is. Music. Music